In this video, we're going to have a look at how we deal with what's called 2's complement, which is negative binary numbers. So far we've had a look at positive ones. So positive, let's take for example the number 14. So 14 in 4 bits, got 1, 2, 4, 8. 14, 1, 8 plus 4 gives us 12 plus 2 gives us 14. So there is the 4-bit version of 14. Where it starts to get a little bit complicated or a little bit different is when we start to deal with negative numbers, because negative numbers, how do we get them in our scale? If we're dealing with 8 bits, we've got the headings 1, 2, 4, 8, 16, 32, 64 and 128. No room for any negatives. So for a negative number, the most significant bit has to be negative itself. So looking at this scale here, the most significant bit is the one on the right hand side, and therefore that 128 becomes minus 128. If we use 4 bits, the most significant bit here is minus 8. So by doing that, that's what we call 2's complement. 2's complement, negative numbers, although we can still represent positive numbers too. So I'll take that negative numbers off there, but what we are looking at here are some negative numbers. Okay, so let's have a look at an example. If we've got a binary number 1, 0, 1, 0, and we're told that that is a 2's complement number, we know it is negative because the most significant bit is a 1. 1, 2, 4, minus 8. So therefore we've got minus 8 plus 2 equals minus 6. So this number here is negative 6. If we've still got a 4-bit 2's complement number and we're representing this, that is still a positive number because we've got no minus 8s, but we've got a 4 plus a 2. So that is 6, or positive 6. So a 2's complement number means that that number, the most significant bit, is representative of a negative number. Okay, let's take a slightly bigger one. Well, let's go for something. Imagine if we would like to convert a number, something like 60, and we would like the negative version of 60. What we can do, 1, 2, 4, 8, 16, 32, negative 64. And we can work from there. We can say, well, we'll start with minus 64 and we'll add 4 to it. And that will give us minus 60. Another way, let's start with 60. 60 would be 32 plus 16 gives us 48, plus 8, 56, plus 4, 60. So that is 60, still in 2's complement because I've still got the most significant bit as negative, but that's representative of its positive number. Now 2's complement states that starting from the right hand side, this side here, up to and including the first one, leave the bits as they are. So up to and including the first one, I'm going to leave as is. After that, the numbers will complement each other. 1 becomes 0 and 0 becomes 1. So the 1 there becomes 0, 1 becomes 0, 1 becomes 0, and the 0 becomes 1. And what we end up with is the negative version of that number. Now we can check this because we did it another way there. And that shows that we've got minus 60 working through it that way, or using the 2's complement rule, we've got minus 60 there. Okay, we'll have a look at one more. So I've got the number 84, and I would like to find minus 84. 1, 2, 4, 8, 16, 32, 64, minus 128. Now it may be that you start thinking, oh, minus 128, what do I add to that to get this? So sometimes the easiest way is to actually find out the positive version, e.g. of 84. So I've got no 128. I've got 164. So 84 minus 64, I've got 20 left to find. No 32s, I've got 16. 4 left to find. No 8. There's a 4. 0, 0. So here is my positive version of 84 in a 2's complement number. That is still a 2's complement number because the most significant bit is negative. Using the 2's complement rule, up to and including the first one from the right hand side, I leave as is. Then every other bit I swap. Vice versa, 1 for 0, 0 for 1. If I was to try this on a calculator, minus 128 plus 32 plus 8 plus 4, so that's minus 128 plus 44 equals minus 84. So there is the 2's complement version, minus 84. Okay folks, that's a little tutorial on what a 2's complement number is. Thank you very much.